In this section, we're going to be talking about standard deviation, the empirical rule, and z-scores. As a reminder, we use the mean as the measure of central tendency when your data is symmetric or basically symmetric with no outliers. We use the median if your data is skewed or if it has one or more outliers. A measure of variability should be coupled with a measure of center to help us understand whether most of the observations are close to the typical value or far away from it. So there are two different measures here. We've got a measure of central or central tendency, which we've already discussed, and that would be either our mean or our median. But we want to couple with that a measure of what we call variability. So it takes two of these different measurements to give you a good idea of what's going on. If the median is determined to be your best measure of center, then the IQR is the corresponding best measure of spread. However, if you determine that the mean is the best measure of center, then the standard deviation is the corresponding best measure of spread. So the standard deviation is a number that measures how far away the typical observation is from the mean. It's best used for symmetric data, kind of like what we've already said. And when you couple that standard deviation with the mean, it gives you a well-rounded picture of what's happening with your data. It doesn't really help to give the center of your data, what's the typical value, if we don't also talk about, well, how far are the other values from that? Are they very spread out or are they not very spread out? The variance is another definition, another word you'll see. It's also a measure of spread. It is the standard deviation squared, or S squared. So standard deviation is a lot of times given with an S. So then variance would be taking that and squaring it. For most applications, and especially what we do, the standard deviation is preferred over the variance because the standard deviation has the same units as your mean. Whereas the variance, you square it, and so then it has squared units, and a lot of time that then loses meaning. So let's say we're talking about time, so we can say the mean time, and then standard deviation would give us kind of a plus or minus amount of time that we can expect our values to fall between, and time squared, other than being a place, squared time doesn't really mean anything. It lost meaning right there when we squared it. So yes, variance is another calculation of spread. We can calculate it. You could be asked to find it in problems, but for most application purposes, we don't really use it because it stops making sense. So how do we calculate standard deviation? It's actually quite a complicated formula. Depending on whether you're using a sample or a population, the notation and the formulas change a little bit. If we're talking about the size of a sample, we use a small n for how many are in our sample. And if we're talking about a whole population, we use a capital N. Now we know how to find the mean of both or of either a sample or a population. So again, the notations though are x bar is the mean of a sample. Mu is the mean of a population. And what both of these notations are saying, this big symbol right here means sum. So it means you're going to add up basically all of your values, and then you're going to divide by how many you have, which is the same thing as taking 1 over n. That's the same thing as dividing by n. So this is just fancy notation for telling us exactly what we know already, which is how do I calculate a mean? I add up all the values and I divide by however many I had. Okay, that's what both of these notations are saying there. Now, how do I find the standard deviation? Well, look at those formulas. They are very large and very complicated, and they take a long time to do, and you could do them because there's nothing in it that's any more difficult than adding values, subtracting values, squaring values, and dividing. But it just takes a very long time to do by hand. Hence, we will not be doing it by hand. We will only be calculating standard deviation using technology. But what I do want to call your attention to is that in these, it's not just a difference in the notation, but there's actually a difference in the calculations. And so it's going to matter when you go into your technology that you tell it to calculate the correct kind of standard deviation. When you're dealing with a sample, you don't divide by the values, the number of values you have, you divide by one less than that, n minus 1. However, in the whole population, you still just divide by n, the total amount of values that you have. And I'm not going to get too far into why this happens. It has to do with the idea that if you've taken a sample, you don't know what that population value is, and you're probably underestimating it, is the idea. Anytime you take a standard deviation, you're probably calculating a larger standard deviation than what it actually is. So this formula compensates for that. And then this formula doesn't have any compensating it needs to do because you're actually calculating the whole population, so you don't have to try to like compensate and get closer to the real value. But you don't need to necessarily worry about that. What I just need you to worry about is the fact that there is a difference between the two formulas. So when you're in the technology, you want to make sure that you tell it appropriately based on the question that you've read and that you're working on. Is it a sample standard deviation that you're working on, or is it a population? And make sure that you use the correct command inside the technology. So let's take a look at what exactly does the standard deviation add to what we know about data, because we've talked about the mean a lot. What does the standard deviation give us beyond that? Like, why is it important to have this second measurement coupled with it, like I've been saying? So here's a graph that compares side-by-side exam scores of two different classes. Class A is in the light blue and Class B is in the dark blue. We want to say, what is the approximate mean for each of the classes? So if I kind of just try to force myself only to look at these light blue bars, it looks pretty symmetric, and it looks like the center is honestly probably right around here. So somewhere in that about a 50 score. And then if I look at the dark blue bars, it also looks pretty symmetric. And its center looks like it's probably about the same. Like it's also right about there in the center. I'd say it probably also has a mean of around 50. However, these two classes definitely did not perform in the same way on this exam. There is something very different going on with them. So which of these classes has the higher standard deviation of exam scores, and what does that mean? Well, the higher standard deviation would be Class B. So it's going to have the larger standard deviation because what that means is that the scores are more spread out and they're farther from the mean. So in Class A, there was about a 50% or a 50-point maybe average grade, and everyone scored very close to that. The highest score was around a 60, maybe a little over a 60, and the lowest scores were maybe down about 30, a little above 30. So everyone scored pretty close around that 50 mark. However, with Class B, they're totally spread out. Yes, the middle, the average was about a 50, but you have students scoring way up in the 90s. You also have students scoring down below the 10 mark. So how I as an instructor would respond to those two classes would be very different. For the classes where everyone scored similarly, I know that all the students in that class are, they're basically on the same level of understanding, give or take. I probably don't need to do any giant class interventions, but maybe I just need to talk to like those few students who didn't score as well as we would have liked. However, With Class B, those students are all over the place in their understanding. Some understand it very well, a few very not as well. Then I have them kind of all scattered in the middle. And so how I would respond to that and what I would do next would be very different. So this is why the mean does not give you a full picture of what's going on. You need that standard deviation, that spread measurement as well, to really understand the full picture.